Hello and welcome. This will be a comprehensive guide to Azure Synapse Analytics. In this video, we will explore 7 essential components that make this powerful analytics service a game changer for data professionals. Let me start by drawing out our journey as we talk. So, Azure Synapse Analytics begins with a workspace, which serves as our central hub from where we branch into three powerful analysis engines. Let me first create the Synapse workspace. Now we will branch into three powerful analysis engine inside here. So let me create boxes for each one. This will be our Apache Spark, and here will be our serverless SQL, and the third one will be our dedicated SQL pool. So these, let me connect these here as well. So now we have our analysis using serverless SQL, Apache Spark, and dedicated SQL pool. And using these, we will feed our data into a storage analysis capabilities, leading to pipeline orchestration, and finally connecting to Power BI for visualization. Now, so we will be feeding our data into a storage account. Let me connect these as well. So after the storage account, we will create a pipeline orchestration. This will be the pipeline orchestration. And then after these, we will create a Power BI visualization. So let me explain. The Synapse workspace is your unified environment for data ingestion, enterprise data warehousing, and big data analytics. Think of it as your command center where you can seamlessly switch between different analytics engines. It provides built-in security with Azure Active Directory integration, enables cross-service collaboration between teams, offer integrated CI/CD capabilities for DevOps practices, and provides a unified experience for data ingestion, preparation, management, and service. Now we will move on to serverless SQL. Serverless SQL pools represent a revolution in data analytics. They offer pay per query pricing model, meaning you only pay for what you use. Zero infrastructure management overhead. Ability to query data in various formats including Parquet, CSV, and JSON. Automatic scaling based on your workload, built-in data visualization capabilities, and advanced T-SQL capabilities for complex analytics. Now, let's move to Apache Spark. Apache Spark in Synapse brings a massive distributed processing power, so it supports multiple programming languages including Python, Scala, and .NET. It has built-in machine learning libraries for advanced analytics, Delta Lake integration for reliable data lakes, automated resource management and scaling, seamless integration with Azure ML. and real-time processing capabilities. Now, for dedicated SQL pool, these are pools provided by enterprise-grade data warehousing. So they have massive parallel processing architecture, predictable performance and costs, built-in workload management capabilities, and column store indexing for optimal query performance. It also has advanced security features including row-level security and include integrated polybase for external data access. So for storage account analysis in Synapse, it offers native integration with Azure Data Lake Storage Gen 2, hierarchical namespace for efficient data organization, and built-in exploration capabilities. It also offers automated data discoveries and classification, integrated data lineage tracking, and support for multiple file formats and encoding types. Now, for pipeline orchestration, it provides visual pipeline development interface, 90 plus built-in connectors for data integration, advanced scheduling capabilities, data flow transformation without coding, built-in monitoring and alerting, and integration with Azure DevOps for CI/CD. The Power BI integration completes our analytics journey with direct query capabilities for real-time analytics, thematic model integration, automated refreshing scheduling, and enterprise-grade security inheritance. It also has collaborative development features and cross-workspace linking capabilities. So, this integrated analytics service brings together the best of Microsoft's data platform capabilities. Understanding these components help you leverage the full power of Azure Synapse Analytics. Thank you. Hello and welcome. In this video, we will create a Synapse workspace and then afterwards we will be performing some operations and uploading some data into it. So let's get started. So first go on to your Azure portal and let's search for Synapse. Now in the search results, let's select Azure Synapse Analytics and click on Create to create a workspace. So the first thing, you have to select your subscription and now let's create a new resource group. Let's pick any new name. This should work and you can leave this manage resource group empty. Now scroll down inside the workspace name. We can pick any name that is globally unique. Let's give my Synapse workspace and it's not available, so just add some numbers in next to it. Now let's select a region. Pick a region where you have your data or where you want your client applications or services. I'm selecting Central India because it is pretty close to me. Now under Data Lake Storage Generation 2, what we can do is select our account name. So as you can see here, Data Lake Gen 2 is required. So what it will do is we can create new Data Lake Gen 2. Let's give the name as it's already taken. So 11211. Okay, this is available. This will create a new Data Lake Gen 2. Now under file system, we will also create a new file system. Let's give it users and click on OK. Now the workspace will use this storage account by the name of Contoso Lake and the file system will be users and this will be the primary storage account to store the Spark tables and Spark application logs. Now you must check this box. This will assign you the storage blob data contributor role on the data lake storage that you just created. Now click on review and create, and after a few validation checks, we will be able to click on this create button to create our new Synapse workspace. And this will take a few minutes to get ready. Our deployment is under progress. Now let's wait for the Synapse Studio to get started, and the deployment for our Synapse workspace is completed. Now let's go to resource, and here you can see it has our Synapse resource group, and you can see the Synapse workspace as well as the storage account. So we have to open our Synapse workspace. So go to your Synapse workspace, and here you can see this is the overview of the Synapse workspace. So how we can open the Synapse Studio? So let's go to a new tab and type web.azure. Okay, there is a spelling mistake. Synapse.net. So this will open our Synapse Studio, and let's wait for it. And here you can see it is asking us to provide a few details. So let me log in. So this is my Synapse workspace, and it has already selected my Microsoft ID. Now click on continue. This will log into our Synapse workspace. The next thing we are going to do inside Synapse workspace is place some sample data into the primary storage account. So we are going to use a small row sample data of New York taxi cab, and we will begin by placing it in the primary storage account that we created. So before that, let's download the dataset. So create a new tab and type NYC taxi dataset. And here you can see the nyc.gov website. Now scroll down to N and let's expand any of the year. I am expanding 2023, and we will be downloading the green taxi trip records in Parquet format. A single month data is more than enough for our lab. So let's click on the data, and this will automatically download our data. And here you can see green trip data for January month is being downloaded. So uh, we also need to rename this data. So let's do that as well. Let's give this name NYC trip small. And next thing, what we're going to do is using Synapse Studio, we will upload this data. So how to do that? Let's go to Synapse Studio, and on the left hand column, navigate to the data hub, and now let's select linked, and here we have our linked Azure data lake. Now you will see my Synapse news, which is primary. So let's select this container. Now you will see a users. Now select this, and here we will be able to upload our Parquet file. So click on upload, and let's browse. Here you can see NYC trip small dot Parquet. Now let's open it and click on upload. and our file has been uploaded. Now, in the next video, we are going to analyze this data using a serverless SQL pool. Thank you so much. Hello and welcome. In this tutorial, we will learn how to analyze data with a serverless SQL pool. A serverless SQL pool let us use SQL without having to reserve capacity. Billing for a serverless SQL pool is based on the amount of data processed to run the query and not the number of nodes used to run the query. Every Synapse workspace comes with a pre-configured SQL pool that is called built-in. So let's analyze the NYC taxi data with a serverless SQL pool. To do so, on the Synapse Studio, on the left-hand side, go to the Develop Hub. Inside the Develop Hub, we need to create a new SQL script. How to do so? Click on Add New Resource and select the first option, SQL script. Now, let's enter the SQL query to select the top 100 rows. Let's give select and here top 100 and then star. Now from give open row set then bracket give bulk and inside here we will give the URL to our data that we uploaded. Let me first leave it empty, then I will tell you how to get the URL. Let's give format and our format for our data is parakeet. So now as result. So the URL for our data will start with HTTPS and next will be the name of our data lake storage. So let's get the name of our data lake storage. Here you can see our data lake storage is named as Contoso Lake and Fund1211. So let's paste it here and then dot dfs dot core dot windows dot net slash users slash the name of our file that was nyc trip and small dot parky. You can also get this from your data lake storage. Go to your containers. Now inside your users container, let's double click and here you can see the URL. Let's copy it and you can also paste this URL in here. Let me show you that there is no change from what I have typed. Here you can see the same file and the same URL. Now let's select run. This will update our query and let's wait for the result. Let me zoom out. Here you can see the result of our query and the top 100 rows. So data exploration is just a simplified scenario where you can understand the basics of and the characteristics of your data. Next thing we will do is create a data exploration database. So we can browse the content of our files directly via the master database. And for some simple exploration scenarios, you do not need to create a separate database. However, you can continue data exploration and you might want to create some utility objects. Those utility objects include external data sources that represent the named references for storage accounts, database scoped credentials that enable you to specify how to authenticate external data source, and database users with the permission to access some data sources or database objects, and utility views, procedures, and functions that you can use in queries. Now, let's create a separate database for custom database objects. Inside the SQL query, now let's move to the next line and type create database, and let's give the name of our database as database exploration DB, and in the next line give collate, and let's give a collation type. So our collation type will be Latin 1 underscore general 1 underscore 100 underscore bin 2 underscore UTF 8. So we use a collation with UTF-8 suffix to ensure that UTF-8 text is properly converted into varchar columns, and this Latin 1 general 1 bin to UTF-8 provides the best performance in queries that read data from Parquet files and Azure Cosmos DB containers. Now, switch database context. How to do so? First, let's run this query, select and run. Okay, there is some issue here. I mistakenly wrote general 1, which was not what we needed. So let's rerun this query to create a new database, and our query executed successfully. Now we will switch the database context from currently master to the new database that we created. How? Let's write the query use database and the database name. So it's name data exploration DB, and let's select this and run to switch our context from master to this data that we just created. Now from data exploration DB, we will create a utility objects such as credentials and data sources. So let's use the command or query create external data source, and the name of our data lake storage. Let's copy it, and in the next line we will give with bracket location and the location of our data lake storage. So either we can copy up till .NET from the bulk path. Let's do this. Or you can go to data lake storage and get your URL. Now Let's run this. So our query executed successfully. And optionally, we can use newly created Data Exploration DB database to create a login for a user in Data Exploration DB that will access external data. How we can do that? In the next line, we will use the query create login and let's give the name data underscore explorer and then the password with password and let's give a password here. Let's give and let's give semicolon. Now let's run this query to create a new login. Our query executed successfully. Now the next thing is to create database user for the above login and grant the administrator database bulk operation permission. Let me write the query and this is the query to create database user in data exploration DB for the login and grant him or her the administer database bulk operation permission. So let's select and run this query. It ran successfully. Now let's explore the content of the file using the relative path and the data source. And here is the query to explore the content of the file using the relative path and the data source. Now let's run this and wait. Here you can see the result of our query. It ran successfully. Now let's publish our changes to the workspace. Click on Publish All and click on Publish. Data Exploration Database is just a simple placeholder where you can store your utility objects. Synapse SQL Pool enables you to do much more and create a logical data warehouse, a relational layer built on top of Azure data sources. This is all for this session. In the next video, we will learn how to analyze data with a serverless Spark pool. Thank you. Hello and welcome. In this tutorial, we will learn the basic steps to load and analyze data with Apache Spark or Azure Synapse. Before learning, make sure that you have placed the sample data in the primary storage account. Now, we will create a serverless Apache Spark pool inside our Azure Synapse. So let's get started. On the left hand side, go to Manage and here we will select Apache Spark Pools. Now click on New and let's give the name for our Apache Spark pool as Spark 1. For the node size, we will select Small and number of nodes, set the minimum 3 to maximum 3. Now click on Review and Create. Now create. Now let's understand serverless Apache Spark pools while it is being deployed. A serverless Spark pool is a way of indicating how a user wants to work with Spark. When you start a pool, A Spark session is created if needed. The pool controls how many Spark resources will be used by that session and how long the session will last before it automatically pauses. You pay for Spark resources used during that session and not for the pool itself. This way, a Spark pool lets you use Apache Spark without managing clusters. This is similar to how a serverless SQL pool works. Now let's analyze the NYC taxi data with Spark pool. On the Synapse Studio on the left-hand pane, go to Develop Hub. Now we will create a new notebook. So click on the plus icon next to Develop and select Notebook. And here you can see a Spark session has been created. And we have to attach a Spark pool that we just created. So let's select Spark 1. We can also rename the notebook from here, but let's do it later. Now in the new cell, we will write a code to create a DF. So type double percentage PySpark and df equals to spark dot read dot load, and then we will give the path to our nyc trip file, and this time the path will start from abs abfss colon double slash users at the rate our data lake storage name. So let's get the name, copy it, paste it, dot dfs dot core dot windows dot net slash the file name. And now we will give the format of our file name, and our format is parquet. Now in the next line we will display our df with 10 lines. So how we can do that? Just type display and bracket df dot limit, and let's give 10. Now as we have attached our Spark pool, we can just run the cell and click on run all because there is only one cell, or we can individually run the cell. This will take about 2 to 5 minutes to be created. And once a Spark session is created, the execution of cell will take about 5 seconds. So let's wait. Now, after about 4.5 minutes, we are able to see the result of our display DF. And here you can see this is our New York taxi file, and it has displayed just 10 rows as we specified. Now let's create a new cell. So click on code, and we can also create a new cell below this so that we can work on our data. So let's delete this cell. Now scroll down and you will see code. Now let's just display the schema. So type double percentage PySpark and df dot print schema. This will print the schema. Press shift plus enter to run that individual cell. And here you can see it has displayed the schema. Vendor ID, pickup date time, drop time, and others. Now we will load the NYC taxi data into the Spark NYC taxi database. So our data is available via data frame named DF, and we will load it into a Spark database that is named NYC taxi. So add a new cell and type double percentage by Spark and Spark dot SQL and type create database if not exist, and let's give the name NYC taxi. Now in the next line, let's write df dot write dot mode and then overwrite, and let's save as table, and inside here let's give the name of the table as nyc taxi dot trip. Now let's run this cell. Okay, so there should be a dot after this. Now let's run this cell. This will take a few seconds because it is creating a new database named nyc taxi, and our command has been executed in 15 seconds. Now we will analyze the NYC taxi data using Spark and notebooks. So create a new code cell and let's enter the command df equals to spark.sql, and inside here we will write the SQL query. Select star from NYC taxi dot trip, and in the next line we will display the df. Now let's run this. And here you can see our data is now present and it has been loaded into the NYC taxi that we wanted. Now let's create a new cell. Scroll down. Because I used Shift Enter to run the cell, it was automatically created, but you can create it just by clicking the plus code button. In the new cell, we will analyze this data and save the results into a table called NYC taxi.passenger count stats. So let me write the query. And here you can see I have already written the query, and let's execute it. This will take just a few seconds to run and the cell results will display as such. Now in the next step, hello and welcome. In this tutorial, we will use NYC taxi data to explore a dedicated SQL pool's capabilities. We are going to deploy a dedicated SQL pool using the Azure Synapse workspace, load our data into the pool, and explore the data we have loaded. So let's get started with the creation of our dedicated SQL pool. In the Synapse Studio, on the left pane, select Manage, and under SQL Pools, let's create a new pool. Let's give the name as SQL Pool 1. Now, under Performance Level, drop down to the lowest and select DW1000C. Now, click on Review and Create, and validation was successful. So now click on Create. Our dedicated SQL pool is being deployed. and it will be associated with a SQL database that is also called SQL Pool 1. After the deployment is successful, we will go to the data and workspace to see our database that will be of the similar name as SQL Pool 1. So let's wait for it to deploy. Our SQL pool has been created successfully. Now let's go to the data page, and here you can see our new SQL pool with the same name has been created. So a dedicated SQL pool consumes billable resources as long as it is active. You can pause the pool to reduce the costs. Now let's load the NYC taxi data into our SQL pool 1. Now in the Synapse Studio, on the left hand side, go to Develop Hub, and now let's select the Add button and now create a new SQL script. Now we will select the SQL pool that we just created. To connect, click on Connect to, and here we will select our dedicated SQL pool 1. Now we will create a new table. So let me paste the code, and here is the code. So what it does is the first thing, table creation. It checks if a table named NYC taxi trip small here exists in the dbo.schema. If it does not exist, it creates a new table with several columns representing the taxi trip details. Example, vendor ID and fare amount, trip distance, etc. The table is created with a round robin distribution and a clustered column store index. So the next thing is data loading. After the table is created, it uses the copy into command to load data from a Parquet file that is stored in Azure Data Lake storage, and the URL for our Parquet file is present here. And how you can get this URL? So go to your Azure Data Lake, select users, and here our file is present. Double click on the file, and here you can get the URL. And we will load this data into the NYC taxi trip small table that we just created. It maps specific columns in the Parquet file to the corresponding columns in the table. The file type is defined as Parquet, and several other options like max errors, identity insert are configured for the data load process. Now let's run this query. So select the run button. This script will finish and it will load around 2 million rows of the NYC taxi data into a table called dbo.nyc taxi trip small. Now we will explore the NYC taxi data in the dedicated SQL pool. So in the Synapse Studio on the left pane, go to the Data Hub. Now we will go to the SQL Pool 1 and let's select Tables. And here you can see our table dbo.nyc taxi trip small is present. Now select the plus icon. Now after the table, select the new script and click on the new script button. If you can't select, just select the top 100 rows, and we will clear this query and replace it with the query or the SQL script we want. Now let me just copy the script. So you can see this is the query we are going to run. Let me explain what it does. The passenger count, it changes the number of passengers in a taxi ride and this is aliased as passenger count. Now the sum or the trip distance. It will calculate the total distance of the taxi rides grouped by number of passengers. This gives us the sum of trip distance values for each group of passenger count and it is aliased as sum trip distance underscore miles. Next, average. The average distance of taxi rides grouped by the number of passengers. It calculates the average value of trip distance for each group and is aliased as average trip distance underscore miles. Now the data is selected from the table dbo.nyc taxi trip small, which contains the record of the taxi trips, and the where tag will filter the data to include only records where trip distance is greater than 0 and passenger count is also greater than 0. This removes invalid or incomplete data such as trips with 0 or negative distances or 0 passengers. Group by. This data is grouped by passenger count. This means that for each unique number of passengers, it calculates the sum and average of trip distance. And into dbo.passenger_count_stats, this clause creates a new table called dbo.passenger_count_stats to store the results of the aggregation, such as passenger count, sum of trip distances, and average trip distances. And if the table does not exist, it will create it. Now, the DBO select query, what it does is retrieves all the data from the rows in the dbo.passenger_count_stats table that was created in above, and this table will contain the aggregated statistics by passenger count and order it by passenger count. This will display the results and sort it in ascending order based on the passenger count column. This means the data will be listed starting from the lowest number of passengers to the highest. Now let's run it. And in the SQL script result window, we will change the view to chart to see a visualization of the results as a line chart. Now let's also change the category column to passenger count. Now make sure to delete or pause your dedicated SQL pool to reduce costs. How we can do that is go to manage and select your SQL pool and click on this pause button. This will pause and you will not be billed. Thank you. Hello and welcome. In this tutorial, we will learn how to analyze data that is located in a storage account. So far, we have covered the scenarios where data resides in database in the workspace. Now, I will show you how to work with files in storage account. In this scenario, we will use the primary storage account of the workspace and the container we specified when creating the workspace. And the name of the container or the storage account is, let me show you, Contoso Lake 11211 and the container name is users. Now we will create a CSV file and Parquet files in our storage account. Now how to do that? Go to Azure Synapse and Now go to Develop Hub and select your notebook that you previously created. Now create a new cell below the previous cells and write the code. Let me write it here. This repartition equals to 1 ensures that we will get a single file during the write command. Now in the next line, give df dot write dot mode, and the mode we are going to use is override. Now dot csv. Now let's give the path slash nyc taxi, sorry, taxi slash passenger count stats underscore csv format. Now in the next line, df dot write dot mode, again override, and this time parkey dot parkey, and then we will copy the same above path, and instead of csv we will change it to parkey. So let me change it, csv, let's give parkey here. Now let's run this, and our command executed successfully. Now let's analyze the data in the storage account. So go to your storage account and go to users, and here you can see NYC taxi new folder has been created, and two folders for CSV format and Parquet format each. We can also analyze the data in our Synapse Studio. So go to Data Hub on the left pane. Now go to Linked, and here you can see our Azure Data Lake storage, and here is the storage that we have. Select users. Here you can see the NYC taxi. Now let's open this. Inside we can see two folders, the same as we saw in the users container. Now let's select any one folder and you can see the part file. Now, now what we are going to do is select the Parquet file and load it into a data frame. So let's go back for the Parquet file, and now let's click on new notebook and select load to data frame. A new notebook will be created with a cell just like this. It will automatically give the name to our storage account and the file name as well. Now let's attach our Spark pool that we created, and let's run this cell. We can click on run cell. And if you run into an error related to lack of ports, another session could be using this Spark pool. Cancel all the existing sessions and retry. Let me show you how we can cancel the session. Go to notebook 1 and on these three dots, let's select manage sessions. Now select cancel all. This will stop all the sessions. And now let's go back to our notebook 2 that we just created. And now let's run it again. This will create a new Spark session for us and we will be able to run this cell. So let's wait for it. Your Spark session executed successfully and here is the result. You can see sum trip distance and average trip distance. Now the next thing is let's go back to the users folder. So go back to the data pane and select users and here you can see the Parquet file that we have. Now select this Parquet file and click on new SQL script and select top 100 rows. Now in the top row, make sure to select the built-in app because we have already paused our dedicated SQL pool. Now let's run this script. Either you can select and run or you can just directly click on run. This will display the top 100 rows of the Parquet file. Our query executed successfully. Now the next step will be to orchestrate activities with the pipeline. Thank you. Hello and welcome. In this tutorial, we will learn how to integrate pipelines and activities using Synapse Studio. The first step is to create a pipeline and a notebook activity. So on the left hand side, go to Integrate Hub. Now select plus and click on Pipeline. This will create a new pipeline. Now let me collapse the integrate or the resource pane so that we have more space. Now expand the Synapse folder under activities and let's drag a notebook object onto the designer space. Now under the settings tab of the notebook, we will use the drop down to select the notebook from our current Synapse workspace. Let's select notebook 2 because it has an active Spark session. The next thing we want to do is schedule our pipeline to run every hour. How we can do that? So click on add trigger and select new/edit. Now choose trigger and click on new. The default trigger name is fine. Now inside the recurrence, change it to every one and let's select hours. Now click on OK and it is giving us that you have to publish for the trigger to be activated. Now click on OK and let's publish all. This will publish our changes. Let's publish. After our changes have been published, a new trigger will be set up. Now, what we can do is force our pipeline to run immediately. So once the pipeline is published, you might want to run it immediately without waiting for an hour to pass. How we can do that? On the same pipeline, click on trigger and let's select trigger now. Our pipeline is still not published, so let's wait for it. It's still under publishing. Our pipeline has been published, so let's trigger it right now. Click on trigger now, click on OK. Now we can also monitor our pipeline execution. So on the left hand pane, go to the monitor hub and you can see our pipeline runs. If you do not get this, you can just select pipeline runs from here. Now you can view that the pipeline start time triggered by how it was triggered and the status, everything. So let's wait for our pipeline to trigger and then we will move on to the next part, which will be to visualize the data with Power BI. Our pipeline executed successfully, and that is all for this video. Thank you so much. Hello and welcome. In this tutorial, we will learn how to create a Power BI workspace, link our Azure Synapse workspace, and create a Power BI dataset that utilizes data in our Azure Synapse workspace. There is a prerequisite to this lab. You need to install Power BI Desktop. Now, let me give you an overview of what we did. So, from the NYC taxi data, we created aggregated datasets in two tables named NYC taxi dot passenger count stats and SQLDB1.dbo dot passenger count stats. And you can link your Power BI workspace to your Azure Synapse workspace. This capability allows you to easily get data into your Power BI workspace. You can edit your Power BI reports directly in your Azure Synapse workspace. So let's get started. The first thing we need to do is create a Power BI workspace. How we can do that? In a new tab, type powerbi.microsoft.com and let's sign in. After signing in, it will look something similar to this. Now, on the left-hand side, select Workspaces, and here we will create a new workspace. So click on New Workspace and let's give it a name. Let's say NYC Taxi Workspace, and it is available. Now click on Apply. The next thing we want to do is link our Azure Synapse Workspace to our new Power BI workspace that we just created. So go back to Azure Synapse Studio and now go to Manage Hub. And now under linked services, we will select a new linked service and let's select Power BI. Now let's set a name as let's say NYC Taxi Workspace 1, and let's also select our workspace that we just created, NYC Taxi Workspace. Now click on Create. Our new linked service will be created. Now let's also publish our changes so that our linked service is published. Next thing we want to do is create a Power BI dataset that uses data in our Azure Synapse workspace. So in your Synapse Studio, go to Develop. Now let's select the Power BI and let's also select our workspace, and under Power BI datasets, click on New Power BI dataset and now select Start, and now select the SQL Pool 1 data source and click on Continue. Now let's download the SQL Pool 1 .pbids file. Our file has been downloaded and now click on continue and let's click close and refresh. So now what we are going to do is open our pbids file. Now let's double click on the pbids file and it will automatically open the Power BI desktop. Now here you can see we have our Power BI desktop open. Now you should get a SQL Server database dialog box. So select Microsoft account and sign in to your account. Let me give my ID and password. After signing in, now click on connect. Let's retry. Okay. And after removing the name of the SQL data pool, we are able to sign in. Now in the navigator dialog box, let's, okay. So currently our SQL pool is paused. So let's restart it and then we will be able to run our Power BI. It's currently resuming. So let's wait for it. Our SQL pool is now online. So let's go back to Power BI and click on refresh. And here we will be able to see our tables. And here you can see our passenger count table as well as the NYC taxi trip small table. So let's select our passenger count table and let it, and now click on load. Now from the left hand side, make sure you are in report view. Now on the right hand side under visualizations, let's first select line chart and here you can see line chart. And now now expand the passenger count stats on the right hand side and let's drag passenger count to the X field or the X axis here and let's drag average trip distance and some trip distance to Y and secondary Y axis. Let's also increase the size and here you can see our table. Now let's go to home tab and click on publish. This will publish or save our changes. Now click on save. Let's choose a file name. Let's give passenger analysis and click on save. In the publish to Power BI window, let's select a destination and let's choose NYC Taxi Workspace. And now click on select. Then now let's wait for it to finish publishing. Now it has finished publishing.